Hi everyone, this video is on exercise 9F question 12. So we have this trigonometric function, x is equal to cosec 5y, and we want to find the derivative in terms of y in part A. So the reason that it says find the derivative in terms of y is because for the convenience, we need to start the differentiation basically with respect to y. So we have the function in terms of y, so that's why it's easier for us to just differentiate and find dx dy at first, unlike the usual cases. So that's the first one. And if you remember from the previous exercises that we had, cosec of any function differentiates to cosec cot. So I'm going to show you now in terms of the formula that you can use. Yeah, so the last time that we had to use this was in question 2. And yeah, so when you have cosec of any function that differentiates to so you first find the derivative of the inside function. In this case, for example, in the general case, if the inner function is kx, you find the derivative of that, which is k, and then dy dx is going to be minus k cosec kx times cot kx. So that's how you find the derivative of cosec kx. Again, this is a standard result, and we are using the standard result just to be quicker. And in this case, now we want to find the derivative of cosec 5y. So the derivative of inside, which is 5y, is just 5. Again, we are differentiating with respect to y. But again, the formula had a negative. So we have minus 5. And then afterwards, it's just writing down cosec 5y, which is the same function basically, copy and pasting that, times cot 5y. So that's the new part from the standard result. So this is dx dy, but the question is actually asking for dy dx, and hopefully you remember that if you have a nice function, so the functions that you are given in A level, almost all the time you are given nice functions, so you don't need to worry about that. Dy dx is equal to 1 over dx dy. It's a very important relation to remember. So in this case, we are going to use that to find dy dx, because the derivative we found is dx dy. So dy dx is equal to the reciprocal of that, which is minus 1, and this negative is just because we have negative 5. 5 times cosec 5y cot 5y. And for part B in question 12, we want to find dy dx in terms of x this time. So notice the difference. The difference here is that dy dx in terms of x, but in the previous part was in terms of y, and all of these are in terms of y. So if we want to find this in terms of x, we can use multiple approaches, but probably the quickest one is using the inverse trigonometric functions, because we are given that x is equal to cosec 5y. So that's the initial function, and we can use the arc cosec to make this into a trigonometric function such that we can write y in terms of x. So it's going to be arc cosec x, which is very long, is equal to 5y, and we want to have this in terms of x, so just divide both sides by 5. We are going to get arc cosec x divided by 5. And before showing how to solve this, I want to remind you of the formula that we use for arc cosec. So as we discussed last time, the standard result for the derivative of arc cosec is that you always have an inner function, and in the simplest case it's probably just x itself. But anyway, so it's the minus the derivative of the inner function over, I'm talking about f, over the absolute value or the modulus of the inner function times the inner function minus 1. So that's the general form for the derivative of r cosec x. And in this case, in order to find the y dx, we are just going to use that as a standard result. So the inner function here, interestingly, is just x. Again, the reason it's x is not 5x, for instance, is because we took the r cosec from both sides, and that made the left hand side to be just r cosec x, and the right hand side to be 5y, and then divided both sides by 5. So that's why we just have r cosec x. So you can always write something like this. For example, the inner function u is equal to x, and then the derivative of that is 1. Just to use that for the formula. So according to the formula, we have a negative, and the derivative function in this case is just 1. So that's the first and initial thing about this. Then we have the modulus. So here it just becomes the modulus of x times the square root of x squared minus 1. Again, the reason is based on the formula. In the numerator we have u dash, in this case is 1, and then in the denominator for the modulus and the square root parts we have just u, which is in this case x. So that's the derivative. Oh, sorry, I forgot to write down this 5, because we had this 5 from before, so it just in the denominator for the entire thing, because yeah, we had that. So yeah, that's how we can do this. There are other ways, but yeah, that's it for this video, and thank you for watching.